All right. Oh, I should have asked, is there any sort of lab associated with what you're doing? Or is this the lab?
This is the lecture. The lab I passed with an A a long time ago.
Oh,
So
good. Oh, good.
yeah.
Okay. Even better. All right. Consider the set of data below. It shows the mass and volume of an unknown metal, excuse me, measured with various devices. This can be used to calculate the density of the metal. It says determine the density of the unknown metal for each trial. Show all work. Which trial would give the most precise value for density? Which trial would give the least precise value? Describe what you can infer about increments of measure found on the balance. In the graduated cylinder used in the trial, you identified as the most precise, as well as the you identified as least precise. Wow, a lot there. Okay, we're going to do this one at a time. So we'll start with trial number one.
Mhm.
Got the mass, we got the volume. On the left here, this has 5 significant figures. You basically count all the digits as a starting point. The one on the right has 3 significant figures. The reason is that 0.0 is included. If it only wanted you to go to 22, it would have 2, but because of the 0.0, it adds to it. So the next thing I'm going to do here is I'm going to quickly look up my significant figure calculator. I found a good one a while back. Let me see if this is it. I haven't used it in a while. Yes, this is it. It's a little bit cumbersome to use. I'm going to go ahead and drop it in the chat here, but you can first just enter the thing that you have. And for example, 22.0, I'm going to snip that in here to see how, so you can see how it works on the other screen. It will also do some math for you as well. So that's one of the reasons I like it. So you enter the number, tells you that it's got 3 significant figures, things like that. Sometimes it's good to have that calculator there just to kind of know, but there are some rules. There's basically rules for trailing zeros and leading zeros, which we'll get to, but okay. So a lot of explanation on the first one. The density is mass divided by volume. So it's this 24.356 over 22.0. So you do divide this and then you round to 3 significant figures because use the minimum, whichever one is the minimum. Is that okay?
Yeah.
Okay. So grab your calculator, I'll grab mine. 24 point. All right, so the answer is, and this is where you have to, because it's 3 significant figures, you want to write out 4 digits at least. These are kind of guidelines. Okay, so 4 digits, you count them all, those are all digits. And then because it's 3 significant figures, we're rounding this 0 and it's going to round up. So this becomes 1.11, and then you need units grams per milliliter.
Okay.
Now they tend to only emphasize significant figures like in the early part of the course, and then it just goes away, just evaporates.
Okay.
I don't make these rules, but that's just the name of the game. And I'll just show you this calculator again. One of the reasons I really like it is it does exactly what we just did with the rounding, so you can always check your answers. See, it's 1.11 there. You just enter the expression and it'll calculate that for you.
Okay.
Okay, now there's a lot here. So let me go back. Determine the density of the unknown metal for each trial. So we did that. Which trial would give you, okay, which trial? Describe what you can infer about the increment measurement found on the balance scratches used in your trial. You identify. Okay, so we got to do all that at the end, I guess. We just need to calculate some density. So I'm going to grab this table one more time, and we'll do the densities here together. All right. Okay, so the way I'd like to do this with you is go down each one and identify the significant figures. So we already talked about there's 5 here, there's 3 here. Number 2 has 3 because there's 3 digits. They're all significant at this point. This one has 2, there's 2 digits. This one has 5, so it's 5 digits. We're not, where we run into issues is starting over here on the right. So these are trailing zeros. Trailing zeros are not counted. So like it's 20 has 2 digits, but it only has 1 significant figure,
Okay.
and that's bad. I mean, it relative to the other ones. Okay.
Uh-huh.
So the trailing ones do not get counted. So this 21.09 only has 4.
Even
22 point,
after if it comes after the 9, I read somewhere that it counts if
let's,
it's after.
let's take a look.
Okay.
That might be an exception here. You are correct. You are correct. So if it's after the decimal point, it is 5. So this would be 4. There's if they're trailing zeros, there's 2 cases. There's, we'll just say left of the decimal. So an example would be like 200. These are not counted. And then there's, if they're in the decimal to the right of the number, right of the last digit, then they are counted. So an example would be like the one we just did there, 22.030. This is counted. There's 5 there. There's also leading zeros, which we haven't seen yet, but we'll maybe see that coming up. Any questions on that? Okay. So we're going to calculate the density in this column over here to the right. And you use the minimum number of significant figures to determine how many to round to. So in the first one we already did, it was 1.11. They all need units. I don't know if you want to just put them one time or, put them in the header, but that's up to you. So
Okay.
this next one's going to have 3 significant figures. This one will have 1 significant figure. This will have 4 significant figures. So we just need to do those calculations here.
Okay.
So this is 1.10. And you do have to write it with that 0 because it tells you that there's 3 significant figures. This one becomes just 1 because of the 1 significant figure. And this becomes 1.092. It's 1.5 at the end, but you round it up to 4. You got 4 and 4 here.
I gotcha. Okay. I followed all that.
Okay, and in between zeros get counted.
Okay.
All right. So we have our densities. We're done with. I'm sorry for the scrolling here, but we're done with determine the density. So the next thing is which trial will give the most precise value for density. And by the way, is this the questions where you got to write 500 words and cite your sources and all that?
No.
Okay. Which trial will give you the most precise value for density? So the one with 4 significant figures down here at the bottom. So you want to say trial number 4. Trial 4 is the most precise.
Is it because it has the most sig figs?
Yes.
Oh, okay.
Yes. That is like by definition what it is.
Okay. Nice. That makes sense. Okay.
Okay. The next question here, it says which trial would give the least precise? That was trial 3.
Okay.
It's the least precise. So the 1 significant figure. All right, so then the next question, we kind of have to break these apart. So the next question, it says, describe what you can infer about the increments of measure found on the balance and graduated cylinder for the most precise and least precise. So in the most precise, it's 24.123 grams on the balance. And what that means is it's accurate to this thousandths place. And there's like up I don't know what kind of balance they're using. It's probably digital, but on the old like mechanical ones, like there'd be a weights for this. There'd be a way to get
Tiny
it
little
accurate.
slider.
Yeah, something
Yeah.
like that.
Uh-huh.
And then so for the graduated cylinder, this one's a little bit easier to explain. There's a mark for 20. Let me do it this way. There's a mark for like 20 right there, 21, 22. And then there's also a mark, there's like 10 in between here, which is gonna be really hard to show. There's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I believe that's 10. And that gives you the 10th. And then what I don't know is whether this 100th place is kind of eyeballing it,
Mm-hmm.
like, because there's a little meniscus, like if it's like, it's pretty much right there on it.
Mm-hmm.
But you can say out to the 100th place,
Okay.
100th versus 1000th. All right, and so the same thing for the least precise, okay, 22 grams. I mean, like the other way to think of this is that all we know is that this is between 21.5 to 22.4, like that. That's all we know. That's maybe the other way they're trying to get you to look at this, because both of those round to 22 grams.
Oh, okay. Yeah.
And then the same thing on the 20 milliliters. This one's even worse. We don't know whether this is 19. Well, I mean, because it's one significant figure, it could be anywhere from 15 to 24 milliliters. Because these both would round to 20 potentially. And I'm not really sure what it's asking for. So this is where I'm taking a little guess.
Mm-hmm.
This is the part where I say I'm not as sure about this stuff,
Mm-hmm.
but you're trying to talk about there's more uncertainty in trial number 3.
Mm-hmm. Okay.
And I would convey that in what you write.
Okay.
All right, so I think that is everything. With these questions, it's really important to answer everything. My experience with Rio Salato is that they really want you to, what's the right word? Reference. They're big on references. Like maybe not in this class, but I've just seen a lot of things kicked back because of that. But
As
you
in
are in there.
citations?
Yes, yes.
Okay.
Citations, like anything that you say, they are very, very adamant that you, and they'll just kick it back with like a 0 and make you redo it. But I don't know. It's kind of, I mean, there's not much more to say on that, I think.
Okay. Yeah, I've seen no mention of, well, I've seen kind of, maybe in the syllabus it says cite your work. But no, the requirements that you mentioned at the beginning of this question does not pertain to this class.
Okay.
So,
All right. I'm ready to move on to the other questions here. Let's go through them in order. I mean, we'll have plenty of time to go through them all, I assume.
yep, yeah, I'm also ready. You send this recording, right?
I I send you the notes right away, and I am very far behind on the recordings, but I'll get caught up probably this weekend.
Okay.
So
Yep.
you'll have them. And once summer starts, so this is basically the last busy week I've got where I'm, 10 hours a day or more. So
Okay.
I'll be able to get them to you. If you need it, you can always just text me and I'll send you the Zoom instead of the YouTube.
Mm-hmm. No
Form.
worries.
Okay, how many significant figures does this have? You just sit there and count 1, 2, 3, 4. No big deal on that.
Mhm.
The whole thing that I was trying to mention though earlier about leading zeros, like occasionally you see a number like this,
Mhm.
and this only has one significant figure, I believe. Let me double check that. Yes. So these are called leading zeros.
Mhm.
They are not counted,
Okay. What if
which
it
is
was what if it was like 2.001?
the in-between ones are always counted. You're only concerned is if they're in front, or all in the back. You know,
All
so like two,
zeros.
yeah, like 2000. So this has 4,
Yeah.
this has 1, and then 0.2000 is 4.
Ugh. Okay.
So it really depends whether they come before or after the decimal.
Okay.
We're gonna do more work with this in some of these problems, so you'll
Okay.
be okay. All right, so order of operations says to do the numerator first. So you have to take 11.1 and subtract 4.25. And you don't have to do this by hand. You know, go to the calculator, 0.1 minus 4.25, and your answer is 6.85. Okay. 3 significant figures on the first one, 3 significant figures on the second one, that's fine. Divided by 125. If these were different significant figures, you'd have to round here and then divide by this number. You don't wait till the end. It's intermediate calculations have to be handled with the significant figures.
Say that one more time.
So intermediate calculations have to be done with significant figures. So like I'd have
So
to give you an example.
yeah, like if this top equation had 3 sig figs and then 2, we would have to get the answer down to 2 first.
Yeah, like let's say that this was your numerator,
Yeah.
12.1 minus 10, which is 2.1.
Yeah.
You would then have to say, oh, that's really 2, because this one has on the right has one significant figure that says 3. And then
Oh,
let's say you're dividing by 8.0. You're divided by 8.0. This has 1, this has 2. So even though you get an answer of 0.25, you then have to round to 2.3,
right. Okay.
which could be really far off when you're all done. You're
Yeah.
not going to get that in this class. You're not going to get that's weird stuff, but uh, you'll get like 1 or 2 questions on your midterm on this. Not really emphasized. So you got to
Okay.
divide here. Got 3 on top, 3 on the bottom. This one is let me see here. I don't know why they're doing it this way. So this one ends up being 0.00548,
I have
which is
zero
not enough.
point zero.
I'm sorry. I got an extra 0 there.
That's okay.
Yeah, there it is. I was like, that's not there. Okay. And so where do you stop? Well, there are 3 significant figures in the answer. This has 4. So you have to note around that 8, around the 4 up like that.
Okay.
When you submit your quiz, did you get I know you said you got them right, but does it give you the answers?
It does.
Okay. That would be good to, they tend to draw from the quizzes for the midterms.
Okay, good. Yeah. I reached out to my instructor and asked her for like tips of what I should study, and she was like, "Oh, like the quizzes and the lesson objectives." I'm like, "Okay, that there's like 10 lesson objectives for each
Yeah,
one."
the whole course. Yeah, they're not helpful.
Yeah,
They're all in past experience, they're all available online. Like if you find the right subscription to the right website, you'll probably find old tests
really?
online.
Okay.
Yes. Yes. Okay, so the unit for length
Oh
obviously
yeah,
is meter. This
totally.
is for mass. Seconds is for time, which isn't there. I don't know, something like that. All right, number 4. How many centimeters are in 15 meters? You always start with the given quantity and you write it up top, and then you always multiply by a fraction. You're going to do this a bunch more when you're doing molar masses and other types of calculations.
Okay,
So what goes on the bottom is the same unit that's on the top.
okay.
Okay. So how many meters are in a centimeter, or how many centimeters are in a meter? You're asking the question one way or the other, like how many centimeters are in a meter, which is the way most of us think about it, because
Mhm.
there are 100 centimeters in one meter.
Is that something I'll have to memorize?
Yes, yes.
Oh, okay, that's gross. Okay.
So you may want to ask your teacher list of formulas. Let me see if I can find one real quick. Chemistry. Oh, and okay, and a really good periodic table, like the ones they sell at the bookstore, where they're
Hmm.
kind of the fold outs, the trifolds, they're
Hmm.
laminated. If you can get one of those into the tests, which I mean, I don't know why they wouldn't allow, um, they have like things on there that are going to answer questions. They're going to have like all the work that electron configurations and stuff like that. They're worth picking up, especially as you got to go in person. Get like the
Okay.
maximum chemistry, you know,
Yeah,
thing, periodic table. Like if
biggest.
it's, yeah, quote air quotes. Yeah, this is my periodic table. It's a little book here, but they usually, your teacher's not there to check you in with the
Hmm.
this. So here's a reference I just found that I think I've used before. It's
Okay.
got it's got some of those things that we just talked about, the on the first page there. You've got to know that like centi means 100. It says 10 to the -2, which I don't really love, but uh, something like that. We'll find a better one. But yes, you need to know that. So there are 1,500 centimeters. The units of M do cancel here. Now that I'm looking at that, I don't know. I don't know if I like that one as much, but I'll find another one.
Okay.
Okay, convert 3,500 milliliters to liters. You always start with the given quantity. 3,500 milliliters times. You always put the same quantity on the bottom and then the one you're trying to go to. And you ask yourself, how many liters are in a milliliter, or how many milliliters in a liter? It's typically thought of this way: 1,000 milliliters in 1 liter. You divide and get 3.5 liters. You can also go to Google, right, and do the conversions, but you have to know you have
Right.
to know how to do these for the test. So it's good to work these out. They're going to get more complicated,
Hmm.
but they're all sort of the same. You set them up with the given quantity. So in this case, you start with 150 milligrams times how many milligrams are in a kilogram, and or how many kilograms are in a milligram. And it's again kind of always thought of as a milli is 1,000 milligrams in 1 kilogram. You divide and get 0.150 kilograms. Uh, is seven? I guess seven's degrees C. Yeah, I guess it is. Has to be. Doesn't say. Okay. Room temperature is usually defined as 25 degrees C. The temperature in Kelvin equals the temperature in Celsius plus 273. This is another formula to write down. So you take the given quantity, 25 plus 273, and you get 298 Kelvin. Let's see if I can find a slightly better one of those. Nope. Sorry, I'm just looking to see if I can quickly find a something else, not finding it. Okay. All right, how many centimeters are in 36 inches? Okay. All right, so you start with the given quantity, 36 inches. And then there are conversions between inches to centimeters. I believe that 1 inch is 2.54 centimeters. So this is one of those again that you will have to know. And I don't know. See, I don't know which ones you will need to know.
Right.
So this is one of those where you're gonna have to ask the teacher and say, which ones do I need to know? And can I get a list? And I just don't know why they don't give you the full list of these. This one's slightly better. Drop this in the chat. And we're so used to just going to Google to do this that we never think to do it ourselves, but it's necessary, right? Necessary for this course.
Yeah.
So, all right, let's look at density of lead. All right, if the density of lead is 11.3 grams per centimeter cubed, how much volume would 5 kilograms of lead occupy? Okay. So density we just talked about is mass divided by volume. And we're trying to solve for volume. So my preference is to solve it without the numbers first. And to do that, you can cross multiply here. V times D equals 1 times M. Divide both sides by D. So volume equals mass divided by density. Okay. The mass is 5 kilograms. The density is 11.3 grams per centimeter cubed. So we've got a problem here. The 5 kilograms is not in the right unit of measure. So we need to come off to the side here and convert 5 kilograms to grams. Okay, so it's just like before, it's like how many kilograms are in a gram or how many grams are in a kilograms? 1,000 grams in 1 kilogram, 5,000 grams. This is really 5,000 over 11.3. Now, if you write the units off to the side like this, and you sometimes it's good, they call this check with units. If you multiply the top and bottom by the reciprocal of the units, you see that they cancel. The grams cancel the grams, centimeter cubes cancel centimeters cubed, and the top here the grams cancel gram, leaving you just centimeters cubed, which is your volume. Now you notice none of the answers are in centimeters cubed, they're in milliliters, and that's because 1 centimeter cubed equals 1 milliliter. So that's another kind of thing to know here. Looks like this one's 442 when you do the calculation. Any questions on that?
Yeah, that got to be a little much, but that's okay.
Okay. The next one is kind of like that. It's got more, I mean, they're the most mathy of them, but
Mm-hmm.
the rest look not be too bad. Like it's not calculus. It's basically algebra, not even college algebra. It's solving a few equations. It's not math intensive.
Yeah.
Okay. The density of olive oil, so density is mass over volume. You got to know that. This time we're solving for mass. Mass is density times volume. So you have your density, it's 0.92 grams per centimeter cubed. Your volume is 3 liters. So there's a mismatch in units, centimeters, cubes, and liters. So we convert the liters to milliliters. And it's like, how many liters in a milliliter? How many milliliters in a liter? There are
How
1,000. Sorry.
I'm getting confused with grams per centimeter cubed.
So the density, mass is in grams, volume is in centimeters cubed. So there's, the volume is probably the one I think is most unclear. 1 centimeter cubed is 1 milliliter. Like these are interchangeable.
Okay.
And in the lab, that essay question we did, it was the grams, the mass, the G comes from the mass, and the centimeters cubed comes from the volume.
Okay, okay. Okay.
So this 0.92 grams per centimeter cubed is the density. The volume, we have to convert it to centimeters cubed because we want this to cancel. So on the right here, maybe I should have done this calculation off to the side. So let me do that. Come down here. So the liters cancel, and then 1 milliliter is 1 centimeter cubed. So this becomes 3,000 centimeters cubed. So this is 3,000 centimeters cubed. And so these cancel. So you just multiply the 0.92 times the 3,000, and it looks like you get the 2760 here grams.
A little bit more sense. Yeah.
Okay, so the next problems here are significant figures. All right, so how many significant figures should be in the answer of the following problems? You got to do it problem by problem. This has 2. We just talked about the fact that leading zeros don't count. So you start with the 9, 1, 2, 3, 4, 5. This one's got 5. And so use the smaller one, which is 2. If there were a third number, you'd still use the smaller number.
Mm-hmm.
All right. How many significant figures should be in the answer of the following problem? So you start with this part right here on the top. 5500.1 has 5 significant figures. The 6776 has 4 significant figures. So when you do the division, that's going to have 4. All right, whatever it is. And then you're multiplying by 63690.1, which has 6 significant figures. But you're comparing, you've got 4, you've got 6, so you always use the smaller one, which is 4. Now you could just look at the numbers and say, well, which one has the least significant figures, and go
Mm-hmm.
with that. That's also okay.
Okay.
All right, so these this accuracy and precision thing, they usually give like a bullseye
Yes. Yep.
picture.
Mm-hmm.
I always sort of mess this up, but there's a picture. You can find this one on the web here. I'll snip this in. This is not me. So it always the accurate is when you hit the target, the center. The accurate means like the intended center, and precise is just how close they are together. So it leads to some interesting logic questions, which is like, can something be precise but not accurate, or accurate but not precise? Yeah, I would just get down kind of like there's this is accurate, and then this is precise but not accurate because it's not the center of the target right here.
Mm-hmm.
And then they show you here that it can be both if you have a number of them that hit the center. Does that help?
Yes. Yeah.
Okay. Okay, so here we go. We got 15 kind of as the okay. So we're told that the like true value is 2.73. So there's kind of two ways you can look at it. You try to see like which one is closest to 2.73. And then you might look to see which are the like organized closest together, like without regard to that number. So I'll try to explain that better. Like trial A, it's 2.73. That's kind of okay, but then you got to further away. Trial B is really close together. All these numbers are really close together, but they're not close to the 2.73. So it looks like trial B is precise, but they're not accurate. It's not close to the intended value.
Right.
And then the other ones are kind of difficult to, I mean, A and C, I'm not really sure. We'd have to almost like they're like 2.79 is kind of accurate, but yeah, and 2.77 is kind of accurate, but the rest are not. I guess same with A, like 2.73 is kind of accurate, but the rest are not. So I
Yeah,
suppose that would be the best answer for that.
right. Okay.
All right, so we got a little time left here. Is there something else that you would like us to work on today?
Um, Probably not. I definitely have to, I did guess I didn't realize that those conversions kind of threw me.
Yeah,
And
you're going to get more in the next unit, is my guess. They call them double conversions, things like that.
yeah,
Here's a
that's yeah.
here's another link to a good conversion sheet. So you'll need them for mass, length, temperature. This one's actually pretty good. It's got the prefixes as well. Milli, centi, deci.
Mhm.
I actually like this last one the most. I'm going to save it. All right. Is there
Is it worth asking my instructor if I could bring this to the midterm?
yeah, I would do that. And I'd for sure get a really solid, or ask if you can bring up, I would just be generic, can I bring a periodic table and a conversion table? And,
Yeah.
you know, I would get the most comprehensive periodic table you can get
Okay.
to help you. He or she is not there. They're not checking you in. They're just,
Yeah.
this is good. Is there anything else like us to cover today before we close out?
No, I don't think so. I'll definitely be going